All right, if you're a Flutter developer, you've probably had this nagging thought. What is really going on every single time the build method gets called? It feels like it's happening all the time, and you can't help but wonder, is this killing my app's performance? Well, today we are going under the hood to pull back the curtain and see how Flutter actually renders your UI.
So here's what we're going to cover. First, we'll tackle that big rebuild mystery. Then, we'll dive into the secret weapon behind Flutter's performance. It's 3 trees. From there, we'll trace the life cycle of a single widget, learn some killer tips for writing smarter code, and finally, we'll unlock the secret of keys. Let's get into it.
Okay, first things first. Let's just talk about the elephant in the room, right? That build method. It runs a lot. And if you're new to Flutter, it can feel just plain wrong, like you're doing something incredibly inefficient. So the big question is, does this constant rebuilding mean our app's performance is just doomed from the start?
I mean, it really sounds like it should be, doesn't it? It feels expensive, like it has to be a major performance bottleneck. But the answer is a little more surprising than you might think.
First off, let's just remember what we're aiming for. A beautiful, buttery smooth 60 frames per second. Now, to get that, your screen literally has to repaint itself 60 times every single second. This isn't a Flutter thing, it's just how modern UIs work. It's how video games create that fluid motion. So refreshing the screen constantly, that's not a bug, it's the goal.
So yeah, the refresh rate itself isn't the enemy here. The real performance killer would be if Flutter had to recalculate and redraw every single pixel from scratch 60 times a second. The great news? Flutter is way, way smarter than that. And the way it avoids all that extra work, well, it's kind of brilliant.
And that brilliant solution all comes down to Flutter's core architecture. See, you might think you're just writing code for one tree of widgets, but behind the scenes, Flutter is actually managing 3 separate, distinct trees. This is where all the magic really happens.
So first up, we've got the one you're already familiar with, the widget tree. The best way to think about this is like a blueprint for your UI. It's not the UI itself, it's just a set of instructions. And because it's just a configuration, it's super lightweight, it's immutable, and most importantly, it's designed to be thrown away and rebuilt all the time. It is incredibly cheap to do.
Next up is the element tree. Now, if the widget tree is the blueprint, the element tree is like the sturdy steel frame of a skyscraper. This is the persistent, stable structure that connects your flimsy blueprint to the final thing you see on screen. It manages the widget's lifecycle, and, crucially, this is where the state lives. This tree almost never gets rebuilt.
And finally, we have the render tree. This is the finished building, the actual, tangible pixels that get painted onto the screen. This tree does all the heavy lifting, the layout, the painting, the hit testing. Flutter is extremely protective of this tree and will only update the absolute bare minimum needed to reflect a change.
Okay, so here's where it all comes together. This is the big aha moment. When you call setState, Flutter instantly creates a brand new disposable widget tree, a new blueprint. Then, that stable element tree acts like a diffing engine. It looks at the new blueprint and compares it to the old one. It finds the tiny little differences, updates its own references, and then it tells the super expensive render tree, hey, don't rebuild the entire building. Just go repaint that one window on the 3rd floor. That is the secret to Flutter's incredible performance. You know, understanding the 3 trees is a huge piece of the puzzle. But now let's zoom in a little bit and look at the life of a single stateful widget. We can see how it interacts with that stable element tree from the moment it's born to the moment it's gone. So, a stateful widget has these key moments in its life. Init state runs exactly once, right at the beginning for any initial setup. Then build runs, which we know all about. Now, did update widget is a really interesting one. That gets called when the widget's configuration changes from its parent, like if a title string it's displaying gets updated, but the underlying state object is still the same. And finally, dispose is called at the very end for any cleanup, right before it's removed for good.
And if you take away one thing from this whole explainer, let it be this. Your state, your actual data, that counter variable, that text field input, it is not stored in the disposable widget blueprint. No, it's safely anchored to the persistent element frame. That's it. That's why your counter doesn't reset to 0 every time build runs. The widgets are temporary, but the state endures.
Okay, so now that we've had a peek under the hood, we can actually use this knowledge to write much smarter code. Let's look at a couple of super simple but really powerful ways that we can give Flutter little hints to make it even more efficient. This right here, this might be one of the easiest and biggest performance wins you can get in Flutter.
Just by adding that one little const keyword, you're telling Flutter something really profound about this widget.
You can slap a const on any widget where all of its arguments are known when you're writing the code, not when the app is running. This is basically a signal to Flutter that says, hey, this widget and everything inside it are frozen in time. They will never change. So don't even bother checking this part of the tree during a rebuild. Just grab the old one you already have cached. It's like a get-out-of-jail-free card for the rebuild process.
All right, for our final piece of the puzzle, let's talk about something a little more advanced, but so important, especially when you're working with lists. Let's talk about keys. They are the solution to a super common and really frustrating bug.
You've been there, right? You have a list of stateful items. Maybe each one has a unique color or some text in a field, and when you delete an item from the middle of the list, suddenly all the colors or text of the items below it gets scrambled. It's a classic case of mistaken identity.
And here's exactly why that happens. Without keys, Flutter only has two pieces of information to match a widget to an element, its position in the list and its type. So, when you delete item A from your widget tree, the old element for A, which is still hanging around, looks at the new widget that's moved into its spot, widget B, and it thinks, hey, you're an item widget, I'm an item element, close enough, we must be a match. And then it wrongly applies its old state, item A is red color, onto the innocent widget B.
The solution is simple: a value key. Think of this like giving each widget a unique permanent name tag. So instead of just matching by its type, Flutter can now look for a specific unique ID.
So what this really means is that keys provide a stable identity. Now, when you delete the widget that has the value key ID_A, Flutter knows to remove the element with that same exact key. There's no more guesswork, no more mistaken identity, and the state for item B stays correctly with item B exactly like you wanted.
So let's just quickly recap everything we've uncovered. First, the build method is not the enemy. Rebuilding that widget tree is fast and cheap by design. Second, Flutter's real efficiency comes from that clever three-tree structure. Third, remember that state lives in the stable element, not the disposable widget. And finally, you have two great tools. Use const whenever you can to tell Flutter to skip work, and use keys in lists to give your stateful items a proper, stable identity.
And that is how Flutter really renders your UI. It's not magic, it's just a really clever, really efficient system. So I guess my final question for you is this. Now that you're in on the secret, where's the first place in your own code you're going to go add a const or a value key? Thanks for joining me on this deep dive.